So we have already discussed about immediate addressing mode and register addressing mode. So in case of immediate addressing mode, the 8-bit or 16-bit data is the part of the instruction. And in case of register addressing mode, our data is in one register. So from register to register we will transfer the data. Now we will see direct addressing mode. Now in case of direct addressing mode, the offset address, the offset value of the data is given in the instruction. Okay? For example, move AL, comma, within bracket 1000H. Now, this is the instruction. In this instruction, AL register is our destination, and the address, offset address of our source is given with the instruction. Now, in direct addressing mode, by default, this offset address belongs to data segment only, right? So by default, our data is in data segment and it is 1000H location above the base address of our data segment, right? So offset address means how far it is from the base of our data segment. So by default, in direct addressing mode, the offset address belongs to data segment only. So now in this particular example, suppose this is our memory, this is RAM, and in this RAM, let us assume this portion is our data segment. This portion is our data segment. So in this data segment there are various memory locations. And so total there can be 64K locations, right? 64K location means if suppose this is location number 1, this is location number 2, this is location number 3, then 65,536. So in 64K there are total 65,536 locations. Now this is the base of our data segment. Now offset address means our data is from this base at 1000H location, right? So suppose here, okay, we just what we do. So total there are 65,536 location, but we write the locations in decimal number from 0, right? 0, 1, 2, then in this way this is 65,535. Okay. So let us assume this is at 1000H from the base. So at this particular offset address, offset means how much far it is from the base. So our data is at 1000H locations far from the base, right? So here we are having some data. So always remember, at one location we can have only 8-bit data. So suppose let us assume here we are having some data. We will take some example. Let us assume it is 39H. Some 8-bit number 39H is stored at this particular place, which is 1000 H location offset from the base address. Now, what this instruction will do? It will transfer the data from data segment only, because by default in case of direct addressing mode, this offset address is of data segment only. So what will be the physical address from where data will be moved? Because ultimately your processor has to generate 20-bit physical address, right? So in this case, physical address of data will be segment register value. In the segment register value, we will add one hexadecimal at the right side, at the LSB side. So, or simply you can do one thing, you multiply it by 10, right? Plus offset value. By this we can calculate the physical address from where data will be moved to AL. So let us assume our DS data segment register is having a value 2000H, right? So the physical address from where data will be moved will be 2000H multiplied by 10 plus offset. This is the offset value 1000H, right? So here simply you add 10 2000H. In that you add the offset address. So in this way we will get 21000H. So this is the physical address from where data will be moved in AL register. So in this case, let us assume our data segment is having value 2000H. So in that case, data will be moved from this physical address. So this is a 20-bit address. Now here suppose if we have written the instruction move AX comma 1000H. Now what will happen? So see what is our destination? Destination is 16-bit register. So if a destination is 16-bit register, then 16-bit number will be moved in 16-bit register. Whereas in this case, in the first case, our destination AL register is 8-bit register. That's why 8-bit data whose offset address is 1000H in data segment move to AL register. So whether a 8-bit number will move to the destination or 16-bit number will move to the destination, it will be decided by the size of register at the destination. So here in first case in the destination we are having a 8-bit register. That's why 8-bit number moved to this AL register. But now in this case AX is a destination register and it is a 16-bit register. That's why 16-bit number will be moved. But here in our memory, we can store only 8-bit number at one memory location. Then how 16-bit number, from where 16-bit number will come? So always remember, from this offset 1000H, whatever the offset address is given with the instruction, from that offset address data will be moved in lower register, right? It will move in lower 8-bit register, and from the next offset address. Next offset address is 1001. From the next offset address, data will be moved in higher 8-bit register. Right? So let us assume at 1000H offset we are having data 39H, and at next offset address which is 1001H. At this address, suppose we are having a data A4H, this 8-bit number. And if we execute this instruction, move AX, 1000H. So here what will happen? From 1000H, data will be moved in lower 8-bit register. So lower 8-bit register of AX is, so AX will have, can we split it into two registers, AH and AL, where AL is lower 8-bit register, where lower 8-bit value will be stored, and AH is a higher 8-bit register. So here in this case, data from this offset will be loaded in lower 8-bit register, and lower 8-bit register is AL. So it will be moved in AL. And data from higher address, right, higher offset address will be moved in higher 8-bit register. So now here in this case, data from 1001 offset will be moved in higher register AH. So after move AX, 1000H, if we see the content of AX register, if we observe the content of AX register, so here this is AH and here it is AL. So after the execution of this instruction, you will find content at the lower offset, that is 39, will be moved in lower register, means in AL. And content from the higher offset will be moved in higher register, that is A4 will be moved in higher register, AH. So the content of AX will be A439, which is a 16-bit number. So Intel is having a convention that they have designed the hardware in such a way, whenever there is a movement of 16-bit number, then lower offset address data will be moved in lower 8-bit register, and higher offset data will be moved in higher register. And again, the default segment is always data segment. So what is the physical address? If I ask what is the physical address from where data will be moved in instruction move AX, 1000H. So here physical addresses will be 2. DS into 10 plus 1000H. This is physical address, right? From this address, data will be moved in AL, and from physical address DS into 10 plus 1001H, data will be moved in AH. So physical address for this first case, it is DS. Our DS, we have assumed that it is 2000H. So here we are having 2000 and multiply by 10 means you just add 10 this and plus this offset 1000. So this will give you 21000H, right? So from here data will be moved in AL, and this physical address again DS is same, 2000 into 10 you add 10 plus this offset 1001. So this will be 21001H. So from this physical address data will be moved in AH. So these are physical address. So here in case of direct addressing mode, the default segment is always data segment, and we can move the data in any of the registers, right? So here we can use move bx comma some offset address offset, or move dl comma some offset address, right? Or move ss comma some offset address. Like this we can use any register as a destination. Now if we want that, suppose in this instruction move al comma within bracket 1000h, this offset address should belong to some other segment, and we have written this instruction. So that is not possible. Now what we can do? We can use segment override prefix. So there is segment override prefix. So we can use the segment override prefix just before the offset address, right? For example, move al comma es stand for extra segment colon 1000h. Now if this is the instruction, so again this is a case of direct addressing mode because offset address is given with the instruction. But in this particular case, the segment from where data will be moved will not be data segment because we have used segment override prefix. So this is segment override prefix. So with this what will happen? Now this is the offset address in extra segment, right? So data will be moved from extra segment, right? So in this way we can use segment override prefix. So any segment override prefix we can use. For example, ss colon some offset address or cs colon some offset address, like this. So in this case data will be moved from code segment, in this stack segment, in this extra segment. If nothing is there, just like then data by default it is data segment register, data segment only. So this is about the direct addressing mode. Now we will see register indirect addressing mode. Now in case of register indirect addressing mode, the offset address of our data will be in some register. So content of the register will be the offset address. And which register we can use to store the offset? We cannot use all the registers to store the offset address of our data. So there are fixed registers which we can use. We can use, in case of register indirect addressing mode, we can use register bx, bp, si and di. We can use only these registers to store offset address. Bx and bp are called as base registers, right? Because bp is base pointer and bx is also a register. Bx register, general purpose register. So these two registers are also called as base registers. And si and di are called as index registers. Now, For example, move AL comma BX. So if we are using register indirect addressing mode and our offset address of our data is in any of these registers, then we have to enclose these registers inside the brackets. So here we have enclosed it in bracket. So now this is the example of register indirect addressing mode. Move AX comma BB, move AL comma SI, move AL comma DI. These are the four forms of register indirect addressing mode. So here now what will happen? If we will talk about this instruction. So now the content of BX, whatever is the value of BX, that will be the offset address of our data. Now where is our data? Data can be in data segment, it can be in extra segment, it can be in stack segment, or it can be in port segment. So here always remember, in case of BX register, if BX register is used to store the offset address, then the default segment is data segment. Data will be in data segment. If we have used this instruction where our offset address is in base pointer register, BP register, in that case default segment is stack segment. And in case we have stored our offset address of our data in SI register or DI register, index register, in both of these cases the default segment will be data segment. In both of these cases, default is data segment. Here also data segment. So basically in these four forms of the instructions, in three forms where we are using BX register, SI and DI, data will move from data segment. If we are using BP register, base pointer register, then the data will be moved from stack segment. So we will take one example. Let us assume the value of BX is 1394H. Right? We have loaded this value in BX register, and our data segment value is 4000H. And we have written this instruction, move AL comma BX. So now what will happen? First we will see whether 8-bit data is moved by this instruction or 16-bit data. So for that you just check your destination. Our destination is a 8-bit register. So this will confirm that only 8-bit data will be moved. And now where is our data? So offset address of our data is given by BX register, and by default if we are using BX register, then data will come from data segment only. So in this case the physical address of our data will be DS into 10 plus the value of BX. So data segment is 4000, you add one more zero plus value of BX is 1394. Add this, so now this is the offset, so if you add then you will get 41394H. So this is the physical address from where data will be moved in AL register. Now in the same instruction, if in place of AL, if I am having AX, now what will happen? So now see, the destination is a 16-bit, so 16-bit number will be moved. And we know that at one location of the memory we have only 8-bit. So again, from where 16-bit will come? Whatever is the value in BX, from that offset, data will be moved in lower 8-bit register, right? So here for the AX we have AL and AH. Lower 8-bit register AL and higher 8-bit register AH. So in AH, data will be moved from the offset BX, and in AH, data will be moved from the offset BX plus 1 from this offset. So we see this. Suppose this is our memory. In this memory, this is our data segment. Right? This is our data segment. In that data segment, this is the offset address 139494 H, and this is the offset address after this 1395 H, like this, right? Because offset will start from 0 and it will reach up to F H. It will start from 0000 H. So this is 64 KB. So let us assume at 1394H, at this offset we are having some value 54H, and at next offset we are having some value A3H. Now when we execute this instruction, so data from offset BX of the data segment will be moved in AL. So this is our data segment. In this 1394 is the value of BX. Right? Here we assume that in the BX we are having 1394. From here this data 54 will be moved in AL register. So in AL register we have 54H. And in AH, automatically controller will add 1 in BX. So it will become now 1395H, right? So data from this offset, which is A3, it will move to AH register. So in AH register we have A3H. In this way 16-bit data will be moved. Now other explanation is same. Here in this case the offset address is in BP. Since we are moving a 16-bit in AX, destination is 16-bit register, so data will be moved from two locations, right? Two offset addresses. So whatever is the content of BP, that offset address data will be moved in AL register, and the next offset address data will be moved in AH register, and data will be moved from stack segment only. Because for BP, if we are using BP register, then data will be moved from stack segment. And in this case, move AL comma within bracket SI. So now the offset address is stored in source index register, SI register. And data will be, this is the offset address in this register, and the data segment is the default segment. So data will be moved from default segment at offset pointed by SI register, and it will be moved to AL. So again, in this case, our offset value is stored in destination index register, DI register, and the default segment is data segment. So in all of these instructions, we can use any register. It can be 8-bit register at the destination, it can be 16-bit register. But here, the offset address of our data can be stored only in these four registers: BX, BP, SI, and DI. And for BX, SI, and DI, default segment is DS, and for BP, the default segment is SS, that is stack segment. But if you want to change the segment, then yes, of course, we can do by using segment override prefix. For example, in this first instruction we have written ES colon. Now this is the instruction. Move AL comma ES colon within bracket BX. So now the offset or address of our data is in BX, but now the data will be coming from extra segment because we have used segment override. We have overridden the default segment, right? So any segment we can use now. So now here also we can use suppose SS. So now move AL comma SS colon within bracket SI. So offset address of our data is in SI register, but in this instruction data will come from stack segment. It will not come from the default data segment. It will come from stack segment because we have used here a segment override prefix. Now in next lecture we will see the relative addressing mode and index addressing mode.